Hello, my name is Aaron Summerall, and this is my Physics 2212 Lab 3 Magnetic Field of a Bar Magnet. Introduction, Description / Purpose. To observe and gain a better understanding of magnetic fields. To implement the distance dependence of magnetic fields and the Biot-Savart law to find the magnetic moment of a bar magnet. To observe the relationship between the distance and magnetic fields. The fundamental formulas that were used in this lab, Biot-Savart's law, which is shown right here, and then the distance dependence formula, which is shown right here. The results were mu equaled 2.52426 amps times meters squared, and N value equaled negative 2.9785. Observations throughout this lab. When the magnetometer is a large distance away from the magnet, the magnetic field in the x direction is nearly equal to 0. When the magnetometer is close to the magnet, the x component of the magnetic field increases. The distance of the positions of the phone plays a large role in ensuring that the magnetic field of the Earth doesn't interfere with the readings. Calculations throughout this lab. The distance dependence equation was y equals negative 2.9785x minus 14.499. N was equal to slope, which was negative 2.9785. And to find k, we had to take the natural log of negative 14.499, and that gave us a k value equal to 5.04852 times 10 to the negative 7. Using Biot-Savart's law to determine mu, the radius is equal to 1. Set Biot-Savart's equal to the distance dependence formula, which is shown right here, and that gives us a mu value of 2.52426 amps times meters squared. So right here is the output of the code from GlowScript, and this is sort of a model of a representation through coding of this Lab 3. In the center is the bar magnet, and surrounding it is the magnetic fields and the arrows, and they're pointing in the directions at which the magnetic fields are pointing at that point. And down here is a theoretical electric field surrounding it, and later we'll take the magnitude of this and compare it to the calculations of it, and that's in the calculations portion. Discussion. Model discrepancies. The magnetic field of a bar magnet is very similar to that of the magnetic dipole. In our case, this would make our model of our results very accurate. Sources of error. There could have been human error when placing the phone magnometer. Also, if the magnometer did not match the Earth's magnetic field before the experiment began, it could have skewed the off-axis results in the bar magnet's magnetic field. Additional questions for Lab 3. What if you hadn't oriented the magnometer to align with true north? How would your results have changed? So our numbers would have been skewed because the magnetic field of the Earth would have an effect on the magnetic field of the bar magnet. And this would have altered the numbers and caused there to be a skew in the numbers. What if you were to stick two identical magnets together end to end and run the experiment again? How would you expect your measurements to differ? Well, I would expect that the bar magnet, the magnetic field of the bar magnet would double, and the direction would remain the same. And that concludes Lab 3.